Hello, everyone, and thank you for joining. My name is Shazad Ali, and I'm a product leader in the cybersecurity space. Today, I'm excited to introduce a new platform we are designing called Intelligent PAM Guardians. PAM stands for Privileged Access Management. The vision behind Intelligent PAM Guardian is to build an AI and machine learning native privileged access management platform for modern enterprises. As organizations expand across multi-cloud environments like AWS, Microsoft Azure, GCP, and rely heavily on SaaS platforms such as Snowflake and Salesforce, the privileged access problem has become more complex than ever. Our goal is to leverage cutting-edge machine learning to detect anomalies, access behavior in real time. We also want to reduce standing privileges and proactively secure critical systems before incidents occur. At the same time, we are deeply committed to safe and responsible AI practices. Transparency, privacy, and user trusts are foundational principles for our platform. We clearly communicate how data is collected, how it is processed, and how automated decisions are made. It makes sure that enterprises maintain full visibility and control. In this presentation, I will walk you through the task analysis, user experience design, privacy considerations, and ethical safeguards. If you look at today's process and the products that are providing this type of functionality, their approach is legacy and is very reactive. And if you look at the legacy task flow, what happens that user requests access, then policy engine validates. After that, the access is granted, logs are stored, and security investigations comes after. So the detection is entirely reactive. With this new product, our approach is to embed machine learning driven anomaly detection at the time of access request. So these are the common personas you see in the enterprises today. You have your developers, they're trying to get access to your critical resources. And then you have the security administrators, they are actually monitoring the real-time risk across all the environments. So we wanted to make sure that the user experience is catering for these two important personas. So for example, when a developer would request access, the AI model will evaluate multiple contextual signals simultaneously. For example, time of the request, what time are they trying to get access to, what is the fingerprint of their device, where exactly are they located, are they coming from behind a VPN or from a completely offshore location, what are their historic patterns, and then what about the resource that they're trying to get access to, how sensitive that resource is. Now, in the area of responsible AI, we wanted to make sure we also provide the transparency and also the explainability in the UI design. Security teams don't trust a black box, so we don't want to hide anything in the platform. So the Intelligent PAM Guardian is designed with three pillars of responsible AI that keeps human in the loop and build confidence in the decision the platform will be taking on their behalf. So the first one is the explainable AI outputs. So every decision includes a natural language explanation of what exactly happened and why the system is taking the decision based on the machine learning or AI technology. For example, the access flagged high risk because user has never accessed MongoDB Atlas production at 2 a.m. from this IP range. So that's the type of information or explanation we are providing back to the user. The second is communicating uncertainty. So instead of binary allow or deny, the system actually displays a risk score alongside a confidence interval. So the visual confidence range prevent over automation and make sure that the ambiguous cases receive human reviews before enforcement. The third one is very important, is the continuous feedback loop. This is where the human in the loop comes into the picture, where the human admin will label the model decision as correct, false positive, or missed anomaly. This feedback, which is then combined with the access metadata, behavioral history, and other signals from systems like MCP server, continuously retrain the ML model, and it improves the accuracy over time. From the privacy point of view, this is the privacy first architecture. because we do realize that this system or platform will be used in some critical environments and across multiple verticals, such as financial vertical and healthcare. So we wanted to make sure that the system is processing the sensitive data, including the behavioral metadata, device fingerprints, IP addresses, and the user identity information in a secure and private way. So all the privacy risks across the systems or across through the platform must be addressed by design, not as an afterthought. It is our obligation to minimize the data collection, limit the purpose of it, right to access and deletion, and provide the transparency on the automated decisions. So if you look at our privacy first design controls, you will see the options to minimize the data collection. The behavior analytics is basically randomized, so it's not taking any biased decisions, and it actually decouples from the distinct or direct identities or identifiers. Then we also provide encryption when we are saving this data in rest or data in motion. And you have option in the UI to configure the retention of that data. So the reality is that the AI-driven security system can introduce bias that can impact certain users. So we have made a conscious decision to build this intelligent PAM Guardian platform to proactively identify and mitigate these risks through structured governance controls. So what are those potential sources of biases? For example, there could be a bias based on the location a user is coming from. There might be bias based on the role. Let's say a new employee with limited behavioral baseline joined the company. The system might flag this as a risky user. That might create friction during onboarding when access is most needed. Then we have the biases coming from historical access patterns. So we wanted to make sure that our framework mitigate all those biases. And that's the reason in the product you will see we have the fairness component where we regularly provide the audit scores based on regions and role. Then from the accountability point of view, there is a human in the loop that is responsible for reviewing the access being granted or revoked, especially for high risk denials. Then we also provide the full audit report for every model decision. So you know, or the end user knows clearly what are the capabilities or how the ML machine learning algorithm is taking the actions or providing the response to the admin. Transparency is a key factor. So we have clear transparency. We explain exactly what decisions are being taken by the automation or the machine learning or AI model. And then we also publish these model documentation with clear communication and data usage policies. This is just a snippet of the user interface that we have created. This unified console integrates all 4 design pillars into a single pane of glass. If you look at the task analysis engine, that is the engine that has the real-time access request queue displaying risk scores, confidence intervals, and contextual signal. Then in the product, you see the responsible ML user interface. That's the panel with the natural language decision and why those decisions were taken. There is a feedback button that allows admin to label decisions, and it actually continuously retrain the model through active learning. In the privacy control user interface, you see the data residency map, the encryption status indicator, and configurable retention policies. Last but not the least is the ethical monitoring dashboard. Here, the human in the loop override panel for high-risk denials ensures accountability with full decisions and audit trails. In summary, the intelligent PAM Guardian transforms the privileged access management from a reactive, log-driven process into a proactive, AI and ML-powered security capability that operates across your entire multi-cloud and SaaS environments. It provides the real-time detection. It has the component to reduce the noise so that you don't have the alert fatigue, gives you proper scoring, and the decision is taking. It's not just a yes and no decision. It explains the decision. The privacy is actually built into the platform with the data minimization, randomization, and regional residency. And the ethical governance is part and parcel of this product to make sure that there is a proactive bias auditing element to it, and then also the human in the loop. The intelligent PAM Guardians represent a shift from a reactive security to a proactive AI and ML-driven protection. By embedding machine learning directly into the privilege access flows, we move beyond static policies and after-the-fact log reviews. Instead, we evaluate risk in real time across multiple clouds and SaaS environments. We focus on 4 key areas: clearly defining the problem and simplifying the privilege access task flow, designing a user experience that emphasizes transparency, explainability, build privacy-first data practices aligned with modern regulation, ensuring ethical AI through fairness, accountability, and bias mitigation. Thank you for your time. I look forward to your feedback. Bye.